It's
That's
1.5 as well.
1.5 is the closest, I would say, you know. Moreover, I wouldn't be cool about that.
Oh, yeah, he is.
Okay. Shh. Okay, so Kevin, for number 5, we calculated it out and we came up with 1.
Okay. So make a scatter plot of the data of the 3 data shapes introduced in the reading. Which shape best describes these data? Well,
Wait, which one are we on?
number 6.
Oh, I put hot dog shape.
Okay. Based on the shape of the scatter plot you produced in question 6, what can you say about the appropriateness of using a sample linear regression to model these data?
So I put simple linear regression is appropriate for this data, or these data.
Observations random enough self-efficacy.
Wait, what?
So for number 7, or are you telling me?
Wait, I'm confused. What are we on? We're on 7, right?
Yeah, and
Okay.
I said I chose simple linear regression is appropriate for these data.
Okay.
For number 8, I mean, I put 142, but I'm not entirely sure. I mean, like, I looked in at how many inputs for like the explanatory variable and response variable, and it's like 142, but I'm not entirely sure that's correct.
So
Yeah, what do you guys think?
1.2.
I don't think that's right.
That doesn't make sense to me.
No, it doesn't.
Well, that's the thing. I'm saying for 8, I'm not entirely sure what they're asking, but
They're asking you how much data there is.
well, if that's the case, I mean, 142 should be it.
Oh, did you say 142?
Yeah.
Oh, I'm sorry. I heard 1.2. I was like, that doesn't make sense.
Okay, 142 makes a lot more sense. I was like, 1.2? What?
Are you sure it's 142 though? It's not 139?
Well, go all the way down, and check. I mean, my data stop. Oh wait, hold up. Okay, I was reading from A1 all the way to
No, that's not right.
142. So,
So
basically starts from 4. So it would be 138, I believe.
It's 139. That's weird because my data is different.
what?
Yeah, like when I go on there, it starts at 1. I mean at 2. Because the first line is the gender, the score.
Mine starts at 4.
Mine starts at 2, and if you go all the way down, it ends at 140.
I wonder, I mean, if you
can you
highlight them all, it shows the sum. Oh, here we go. Count. 139.
Told
Okay.
you.
Well, I mean, I can't tell. I mean, it's just the way, that the Excel page is designed.
Yeah, that is weird. But yeah,
But
even
yeah,
if you if you go and you highlight as you're highlighting, it counts them for you.
Well, like if you highlight it, like if you go down to the bottom, there will be an arrow. It says something equals so on. Mine was on sum, but if you go down to count, it'll show how much.
Okay, so let's see, number 9. Use the math self-efficiency data to answer the following questions. What is the y-intercept?
So I put 18.559.
559?
I'm sorry, Kevin. What'd you say?
18.559.
That's what I put.
So you need a thick.
And where did you get that from?
If you need a
How come I don't get that?
So, well, you go down to under standardized.
Yeah, and you look at B, right?
Yeah, BO.
I got 1.291. Did I do something wrong?
Here, go ahead and do the screen share for yours. I want to take a look at yours.
Okay, hold on. Let me go back.
Gosh, this is confusing.
See, mine says 1.1.
You know what? What you did wrong is you copied and pasted exactly. What you're supposed to do is for the explanatory value, you're supposed to put the score, and then for the response. Oh wait, no. For the explanatory, you're supposed to put the confidence. Then for the response variable, you're supposed to put score.
Well, when I did the other one, you mean I see.
Yeah, it says it in number 9. Be sure to use confidence data for the explanatory value variable, and then score data as the response variable, and that's where you're getting it wrong. And you know, like I said, the same like Tuesday, that those are the variable that actually does change. I mean, the R doesn't change.
The Y, the response for this one is the score, right?
So the response is the score. The explanatory is the variable. I mean, the explanatory is the confidence.
Okay.
But it does. I mean, as I said, it says it in number 9.
Oh, okay. Okay, so now I got the 18.559.
All right.
Oh, okay.
And then,
sorry.
And then for the slope in 10, I got 12.725.
Yeah.
And then for 11, I got 69.459.
I'm sorry, what was 10?
For which one?
10?
Well, you were asking what for which one?
10.
10 is 12.725.
What's 11?
Huh? Number what?
11. You guys are kind of halfway cutting in and out.
Yeah. Well,
What's the number 11?
So for number 11, I got 69.459.
That's the equation that we have to do, right?
Well, just as a recap, under X, you would put 4 and enter, and then to the right, you hit the predicted. But
That's right.
You can use the formula as well, but it says in the text that you should use the software because you get a more exact.
Okay. So 11, I got 69.459?
Yeah.
Okay.
And then that's where I stopped at is 12 before I had to, enter the ball again. So the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of Y for these values of X? Your answer should be exact. Hint, because there is a positive correlation, we can use the largest X value to find the largest predicted value of Y. So I guess what they mean by that is you would go to the explanatory variable and you would use the highest one, the maximum.
Which is what I'm looking for. And
you don't have it in order.
No, but you can on the other one, since we're doing it's the X, right? Yeah, the X value. You just you sort them from largest to smallest, and the highest is 100. Wait a minute, is that right? No. Yeah.
So I'm looking at the explanatory variable x, and what I did is I highlighted all of them, and then in the same place where you would switch between like the count and the sum and all that, they actually have the max. They say that the max is 6.
Yeah, sorry, I was doing the wrong one. It's 6.
So
But
it's
just
6?
to make sure.
Yeah.
Okay, yeah, 6 is in there a few times actually. So I guess you would put 6 in x, and let's see, it's asking for the largest predicted value of y. So it is going to be the box to the right of x. So I got
94.909.
Yeah, 94.909.
Yeah.
So what's the answer? 12, 94.909?
Yeah.
How many explanatory independent variables are present in simple linear regression?
Isn't it more than 2? Or am I reading that wrong?
Yeah, I don't know exactly what it is asking.
So, isn't it all the x values?
I think so.
Or
Because it's asking how many explanatory independent variables are present. But I don't know if it's still wait. Yeah, because it's part of this. I think both of 13 and 14 are more than 2, but I'm not sure.
I mean, that would be I guess that would be probably the common guess, but I mean, it just kind of seems like it's a little bit too,
easy?
Yeah, there must be something that we missed.
Yeah. Or it could be just one. Because we're only looking at one, like...
Well, maybe... So simple linear regression, does that change anything? Like, it doesn't say in the data, it just says simple linear regression.
I'm reading something that might be.
That's interesting. So let me go to this. Simple.
I wish I had the computer tonight. So I could tell you something. I have no idea.
Well, I don't know. I mean, right now I'm just looking at text, see if it says anything.
I don't think it does.
Yeah, I don't remember seeing anything that, you know, um,
Wait a minute. Hold on. It's asking us how many responses independent variable present in a sim. I think it's one. In a simple, because it's in the text, it says when we apply simple relation, when the two variables show a linear shape. If the data look in the scatter points, we can include at the small. Sorry, hold on.
well, I would also think it might be one, if not, multiple. But, you know,
Yeah, I think it might
depends
be
on what I'm
one
thinking of, you know, that's
because
like,
it's
oh, go ahead.
no, I think it's one because it's talking about like variable is an independent variable. It's asking about the independent variable. It's just one, and which is the confidence rating mean, and then I think the dependent one is score, or the other way around. I forget which one's which.
You think that I'm sorry, what was that you were thinking of?
So our x value, it's our x variable.
Mm-hmm.
I think when the way they're asking it for a simpler linear regression, you just need to have one, like one variable, which is
The
it could be as many multiple.
See, I'm not entirely sure, but I mean, it might be referring to hold up. Sometime in number 4, it says sometimes it is necessary to use more than one predictor, independent variable to predict the value of a response dependent variable. For example, if we want to predict the stopping distance for a car on dry roads, we might use the initial speed of the car, um, well, or the weight of the car, and then the amount of tread on the tires to predict the distance required to stop the car. That's kind of what I was thinking of, and in that case, both of them, I believe, would be one, but I'm not
Yeah.
sure if that's what it's referring to. But I mean, if it was like if it was what we were initially saying, it could be. I mean, I don't see where they would put like 1, 2, and then more than 2 when there's like 139 answer, or
Yeah.
there's
Yeah.
139 count. So I don't think that's what they're referring to.
Yeah, and on top of that, they already asked that question of us.
Yeah, that's true.
Yep, that's right.
So it's one on both.
Yeah, it's one for sure. I'm 100% confident.
Did you submit?
Yeah.
Okay.
What did you get? 100?
Yep.
Oh, okay.
See, I told you.
Oh.
Sorry. My niece says that all the time. She always tells me, "See, I told you."
Okay, so I'll just go ahead and stop broadcast.